In this lesson, we're going to be looking at balance method solving. Our objectives: understand opposite operations, continued from the last one, and understand how to use balance method to solve. Our vocabulary continues with solving, working backwards using opposites of order of operations to find an unknown number represented by a variable in an equation. The change is we're going to be using a new method called the balance method, which is a way of solving that has operations done to both sides of the equation. For those of you that didn't like the box method, this might be a better situation for your theories of thinking. First, we need to understand exactly what balancing is. Balancing takes into account the equal sign. And what I like to do is sometimes draw a line through the equal sign so that I know what is going on both sides. What we like to do is do the exact same operation to both sides because that would keep both sides balanced. If I add 2 over here, I add 2 over here, which would say x plus 2 equals 11 now. Okay? If I subtract on each side, say I subtract 4, this would give me x minus 4 equals 5. Notice everything's staying in balance from what we started with. This also holds true for multiplication. If I times by 2, well, x times 2 is the same as 2x equals 18. And division, divide by 3. X divided by 3 equals 3. Alright, this is the basic idea of balancing. We're going to do the same thing to both sides, but we're going to keep using the idea of opposites. So if there's adding on one side, then we're probably going to use subtraction, but we're going to have to do it to both sides of the equation to keep it balanced. So here are our first two problems. I'm going to start with the one on the left. I draw my line so that I know my two sides. So what we do is we basically start with the last thing that we would do in the order of operations, which would be this plus 7. We want the plus 7 to go away. Well, to get rid of a positive 7, we subtract 7. These will cancel out. But to keep everything balanced, because right now it's balanced, we need to also subtract 7 on the other side. Then we're going to rewrite everything. Notice the plus 7 is gone because these cancel each other out. Then we would go to the next to last, or the last part that's left. So that would be multiplying by 3. So the opposite of multiplying by 3 is to divide by 3. And I have to do it to both sides of the equation. Now, as soon as there's no math outside the parentheses, we don't need the parentheses anymore. Next step here would be to add 1, or the last step here would be to add 1. We'd multiply and we'd add 1. So we want to get rid of the plus 1. And lastly, we are multiplying by negative 2. We're going to divide by negative 2. And x equals negative 3. Now this is the exact same amount of work as the box method, just a different way of organizing it. So it's going to really come down to which method makes the most sense in your brain. I'm going to do 3 more examples. Okay, last thing we do in this is to subtract 8, so we need to do the opposite. Add 8. Integer math, if you don't know it, review it or use a calculator. Last thing we do here is multiply by 5. Don't need the parentheses anymore because there's no math outside. Okay, let's go on to the problems that can sometimes give us a little bit more challenge or trouble, the decimals and the fractions. Okay, the process is exactly the same. We've just got decimals and fractions in these. So we got to remember our decimal and fraction process. I'm going to use my calculator to help me if necessary. So the first thing I've got to do here, or the last thing that I would do here, is add 3.6. So we got to get rid of that first. It's going to leave me with 17.2. Okay, here I'm going to want to divide by 8. Okay, don't really know that one off the top of my head, so we'll use the calculator to help me out. 17.2 divided by 8. So that's 2.15. And now I'm going to add 4.85 to both sides. And x is, it's going to be 0, carry a 1. That's going to be 0, carry a 1. So I'm going to get 7.00, or just 7. Last is our fraction problem. So remember, with fractions, we're going to need common denominators, and we're going to need to multiply by the reciprocal, or keep change flip. Last thing we do is add 1/5, so we want to subtract 1/5. These have common denominators, so we would just go the top subtracting, so that's going to give me 3/5. Last thing I do here is subtract 1/2, so I want to add 1/2 now. When I add 1/2, I'm going to add it to the side because these need common denominators, so I'm going to rewrite it with a denominator of 10. So if we multiply by 2, so we multiply by 2 on both sides, or top and bottom, we get 6. Multiply by 5 on top and bottom, we get 5. So 6 plus 5, this should be 11 over 10, equals, and now I can bring down my 1/3 x. Okay? Since we're multiplying here, we're going to want to divide by 1/3. But division by a fraction doesn't help us very much. So on the other side, I'm going to multiply by the reciprocal. So I'm going to multiply by 3 over 1. Then it's going to be top times top, bottom times bottom. X is 33 over 10. Okay, if there were any parts of this that you didn't get or you need to watch again, make sure that you pause, rewind, and rewatch, and bring any of your questions to class. Thank you.